Good morning, good afternoon, and good evening to the global audience assembled today. Welcome to the first edition of the Turing Boundaryless Podcast. I'm your host, Krishna Vinod, social media head at Turing. And I'd like everyone to put their hands together for a very, very special guest, Mr. Vijay Krishnan. He is the founder and CTO of Turing.com, headquartered in Palo Alto, California, right in the heart of the Silicon Valley. Turing helps companies hire the top 1% of its 700,000 registered software developers who are vetted over 5 to 10 hours of tests and interviews. Strong software engineers can live anywhere in the world and still have access to the world's best job opportunities. Over 200 companies have hired Turing's engineers, and these include a number of Fortune 500 companies, as well as early stage and unicorn startups backed by A-list Silicon Valley VCs. Turing has been growing rapidly and has raised over $50 million in venture capital. Vijay has worked in machine learning and AI for over 18 years in academia and industry. And today, we will be discussing the $1 trillion problem of matching talent with opportunity and how AI could help solve it. So, with no further ado, welcome Vijay, and tell us a bit more about your story, how you reached this point in your career, founding and leading technology for Turing.
Thanks for inviting me on this podcast, Krishna. I have been working in the field of AI and machine learning for almost 18 years now. My TLDR would be machine learning researcher turned 2x AI entrepreneur. Maybe that's the one-line version of it. I started back in my bachelor's days at IIT Bombay, where I studied computer science. I started in the field of AI and machine learning, wrote some nice papers, mostly on the problems of text categorization, web search, web spam detection, various problems like this, mostly applications of machine learning to text data. I did that both at IIT Bombay, at Stanford University, and even during the time when I was a scientist at Yahoo in the Bay Area. My previous company did personalized content recommendations. So what we did in our previous startup was we would learn what people's interests are based on the content they consumed. So we would use that to build a very detailed profile of users. And we would use that information to recommend other content they may like. So this, of course, involved a lot of deep user profiling and various problems like that. Our company got acquired by Rev Content, an ad tech company where I briefly served as SVP of data science. At Turing, again, I run a lot of our AI and data science efforts as it relates to both data science for various classic business problems, but also the more, I guess, challenging, but also exciting problem of matching talent with the opportunity at a global scale.
Awesome. That is an amazing introduction. And so Vijay, I have a follow-up question to that. I mean, Turing has had the advantage of being remote for quite a few years before everyone else. But for most other companies in the Bay Area as well as other parts of the world, the pandemic kind of forced remote work on them, right? And as a result, they've probably been facing a lot of challenges, which Turing, because Turing evolved into remote work naturally, probably would have some specific insights on how one could go about solving those. What are common things that go wrong in a distributed team, and how should one go about mitigating them?
Yeah, great question, Krishna. And this question is very profound because this also speaks to the question of why didn't remote distributed teams happen earlier? Because on one hand, you would think, it seems completely crazy to restrict your talent pool to a 10-mile radius around where your offices are located when you could hire from the whole world. But obviously, the world did not opt to move in this direction. And it is largely because of a lot of factors, which I think I'll address in this question. The big ticket item is just that I think teams found it very difficult to effectively hire at a global scale. Well, and when I say hire, even that has two parts. How do you effectively source talent at a global scale? How do you effectively screen and vet talent at a global scale so that you ultimately have a very good pool of talent to work with in your team? And number three is how do you make sure that the collaboration itself is effective? Like one very common complaint slash concern I heard from many engineering leaders in the Silicon Valley, even pre-pandemic, used to be something like this. I know it is less competitive and I can hire effectively in other parts of the world. And it could even turn out to be a lot more cost effective. But in the limited experience I've had, 3 people or 5 people in a remote location end up producing the same real value for me that one strong engineer in my office would do. So consequently, what looks attractive at first glance does not really turn into the value I was expecting of it. So I think this is by far the biggest thing. And why does work not effectively turn into value under these circumstances? I think definitely a big part of it, I would say, is just points number 1 and 2. Like a lot of companies, a lot of individuals build very, very strong intuition regarding how to source in their local environment, how to resume a screen in their local environment, and so on. We all develop shortcuts. We have all built certain intuitions here regarding what universities are good, what companies have strong engineers, and things of that sort. But even when it comes to collaboration, one has to be very, very deliberate about making that collaboration effective. In a local office, one does not need to think about this question very much. You see your developers daily. You can assume that your developers will end up mingling with others in the organization, develop more organizational context over time and everything. Ultimately, you want to replicate the same sorts of collaboration, the same sort of value, the same kind of context and everything that a person in your office would have. In a world where all you do is something like throw work over the wall and it comes back exactly with the specifications that you assigned, with this person having no broader context about the company, it is very, very hard to see how such a person could possibly create the same value for you that somebody in your office could create. The person who has a lot of first principle context about your business, and maybe if you go to them with a bunch of specifications, they could come back with an even better idea that addresses the spirit of what you're saying. But in this remote environment, unless you take care to make sure that the same interactions happen, that person would be incapable of doing this. And this is very insidious in a way, because work can have a very strange relationship to value. It is possible to do very similar amounts of work that are vastly different in value than each other. Like taking certain kinds of decisions, choosing to build a product a certain way might be 10 times as valuable as something else. And ultimately, a business, of course, is interested in maximizing value. They are not interested in how hard a person works or anything like that as an end in itself. That is a means to an end of realizing great value. So some practices we have found to be very good in this regard is, one thing we have found very, very indispensable almost is some measure of a time zone overlap. So at Turing, when any of our partner companies in the Bay Area or in the rest of the US for most part hires one of our software developers, we always ensure that a software developer can at least overlap up to 4 hours or more with the company's regular workday. And this we find as being quite vital, because without having enough of an opportunity to unblock, to have certain sort of unplanned communication, you run into this issue of a lot of inefficiencies coming from pure miscommunication and partial context and so on. But again, our experience has shown that something like 4 hours turns out to be very, very good and is almost as good as a full day's worth of overlap. But if you were to really shrink this down to something like an hour or two, often that causes collaborations to sort of go sideways. So this is, I think, certainly very vital. Another thing we have seen to be extremely vital is effective use of video. Now, this may seem like a very small thing, but one of the very understated developments, I would say, in the last 3 years is just the fact that we have been able to get good video to work. Turing was founded in 2018, and I can tell you that even in 2018, video worked fairly well within the United States. It did not work so well when you were doing this kind of cross-border video calls. And the fact that video now works very reliably across so many different countries is very valuable, and one should take full advantage of this. Like an audio call is just not the same thing. I still see so many companies that are going remote first as a result of the pandemic, hiring new people. People do these work Zoom calls where everyone has their video off and nobody builds any kind of connection with anybody else. And such a thing is, of course, a disaster for collaboration. I mean, no wonder, such companies that have failed to get these practices right are desperate to get everybody back into the office as soon as the situation would allow it. So these end up being very, very vital. Another thing that ends up being very vital is really having a process that nudges your remote team members toward over communication. So there's a certain, you can say, taciturn personality type that can function fairly well in an in-office setting. Unfortunately, that requires some change in this all remote world. one needs to over communicate. A company needs to have a process where they ensure that this person actually go and talk with a whole bunch of other loosely related stakeholders, build a one-on-one connection with them over a video call. I think all of these becomes quite vital. Like in an in-office setting, a company wouldn't even think about such matters. They would assume that, okay, this person is hired, this person will end up meeting a bunch of people over lunch and coffee and other things anyway, or will run into them on the hallway. Such things need a little bit more deliberate thought in this remote setting. But once you get this right, of course, you have all the other benefits of this realized for you. You can hire the world's best talent, and it's unbelievable the sorts of competitive advantages this can bring to bear in terms of hiring for speed, quality, and cost all at the same time.
Great points all around, Vijay. So this just brought an interesting point to my mind, and I'd like to tell the viewers who are tuning in that I'm actually based out of Gurgaon, India, which is right next to the capital of India, Delhi. And Vijay is based in Palo Alto, California, and there's a big time zone difference. But working at Turing, it's so easy to kind of forget that people are working from different parts of the world, and I think video has played a key role in that, because I've seen a lot of organizations, both previous organizations and other companies, where people would be on calls all the time, but their videos are off, and new people join in. Especially in the pandemic, people have joined in and they have no idea who their coworkers are. And I definitely feel that that has really been a huge game changer. So, and Vijay, I think that pretty much answers the next question as well. Um, about how one could create and foster a unified company culture in a remote distributed team environment. But if there are any points that you would like to add to this specific question about building a unified company culture?
Yeah, great question, Krishna. I think the main things I would maybe like to add is that today, I don't think companies really pay enough attention to certain kinds of soft skills in the interviewing process. Companies think for most part do a certain amount of technical interviewing. They do a certain amount of nebulous culture fit interviews, though in most cases, I don't think they even have a precise notion of what they are looking for when they say culture fit. I think going forward, it will be making remote work effectively. Really, I see it as a two-part thing. First of all, one should interview for a lot of soft skills that become crucial to remote work, and that should be an important part of the hiring equation itself. So just like, for example, even in office hiring, it is both a question of hiring the right people and also in terms of mentoring them the right way and setting up the sorts of collaboration environment that will allow them to thrive. It is not just what happens after you hire. So here too, I would certainly say that compared to the old school manner of hiring, it becomes important to test how good a person's communication skills are. And when I say communication, I don't just mean English fluency. I also mean matters to do with ownership, matters to do with sort of being able to effectively navigate ambiguity, whether a person is proactive enough to go reach out to a lot of different people in the organization and to sort of get certain things done, or if the person is relatively more passive. And and also whether a person is capable of thinking in objective scope or company scope more broadly rather than merely in task scope. So I think this will become a lot more important going forward, and this should be treated as a very vital hiring signal also. But that said, yes, there is no question at all. Anything at all we can do toward facilitating over communication, facilitating people's interaction with people that they might not normally interact with in the normal course of things, and paying a lot of attention to this whole onboarding process, I think is quite vital. Some of these things I think are a little bit more bleeding edge. I fully expect today at Turing we have a collaboration product that does facilitate over communication. Or nudge developers in the direction of over communication and reporting on where they plan to spend their time in the coming couple of weeks and do these virtual daily stand-ups and so on. But I can also imagine there being ample room for something like virtual mixers. Like I'm looking forward to a product which looks like, I want to say, the modern equivalent of the old school chat room, but applied within a corporate context, where people get a chance to, in a virtual party like sense, mingle with others in different parts of the organization that they might not have normally mingled with. I think often this sort of thing is vital to gaining a broader organizational context and becoming more effective. Plus, of course, needless to say, this makes people feel more connected, and everything gives people a very similar feel to what it might be if they were in an in-office setting, and prevents them from burning out or anything.
Very, very valid points, Vijay. And budding entrepreneurs out there, I'd really recommend that you take note of that point and start working on that virtual mixer setup. Or who knows, Turing might just start it in-house soon. Now, coming to AI and ML, Vijay, where you have a ton of experience, how do you feel the industry overall has evolved over the years? And what is your outlook or advice for the future for companies and developers who wish to realize value with AI?
Yeah, great question, Krishna. So I'm listening to Kai-Fu Lee's audiobook. In fact, I would recommend that to everyone. It's called AI Superpowers, and it's quite interesting because it addresses this question. And more importantly, it also talks a great deal about the use of AI in China and China versus the Silicon Valley and so on, which is also a very interesting thing altogether. But getting specifically to this question, I would say that so when I started in the field of AI and machine, it could do quite well for email spam classification. It could do well for a bunch of other problems. Certainly, some early versions of better ad targeting worked well with machine learning methods as well. But this reboot of neural networks via this deep learning revolution, if you will, in 2012, 2013, definitely is what has sparked a lot of new interest in machine learning and opened up a whole bunch of new avenues. Like prior to 2012 and 2013, like I still remember during my bachelor's degree days and even grad school at Stanford, neural networks promised a lot, but really didn't do very much compared to alternate methods. In fact, the tell for whether somebody knew anything about the field or not is whether they thought about using a neural network. At that time, our joke was something like this. If somebody poses bringing up a neural network back in the mid 2000s, that person is probably from business school and has just read some white papers somewhere. And if the person knows something about the field, the person wouldn't quite be saying that. But yes, I think a number of the previous stumbling blocks that made those things impractical to use got solved. Of course, all the other development helped as well. The increase in computing power, our ability to deal with non-convexity. Now, this was definitely a problem with a lot of the old school methods. I think where we knew how to do convex optimization well, but with these non-convex things, the state of our understanding was still quite nebulous. To be fair, even today, I think a lot of statisticians would still consider our understanding of why deep learning works so well to be quite nebulous. It doesn't fit very neatly into some of the old styles of analysis that worked so well. Like earlier, you could prove all sorts of bounds and you could do all sorts of nice prove various statistical properties. Today, really, the best I suspect we can do with a lot of deep learning is it works so exceedingly well, but we cannot prove any mathematical properties about it. So there's that. But the fact is, yeah, there is no question that there were so many very, very intractable problems almost to do with image understanding, video understanding, speech to text. Even I remember how primitive even a lot of our machine translation methods were between languages and all that. There is no question that being able to effectively learn non-linearities like this via deep learning has opened up a whole new range of problems and possibilities. Of course, once these things have a lot of feedback loop effects, once the world realized that this could be such a massive game changer and produce billions or trillions of value over time, that in turn led to a lot of feedback loop effects. NVIDIA, that was formerly these gaming chips, suddenly became a lot more valuable. And as people started using GPUs for deep learning, of course, Google, Facebook, and so many others started thinking of themselves as AI-first companies, engaged in massive investments in these areas, which, of course, enabled further realizing the potential in these specific areas. So yes, I have no doubt at all that we will continue to realize a lot of benefits from AI and machine learning in the coming years. I think the primary, I would still caution about a couple of things, both to, I think, software developers that are attempting to become better AI engineers, as well as companies that are aiming to use these methods. So today there is this very simplified narrative, which I suspect too many developers and even companies probably buy into, the narrative being that all the machine learning methods have now become commodity. AI can be waved like some kind of a magic wand at your data, and you don't need any high level of competence as a software developer to get there. If you're a regular software developer that's downloaded a few data sets, that's cool because AI somehow works its magic. All you need is a lot of data, and you need some regular software developers, and you can start producing cutting edge AI technology. And I think the reality is nothing could be farther than the truth. Obviously, there are certain attempts being made by some of these larger companies to more sort of democratize AI itself and make it more widely available to a larger set of people. But there is no question at all. Your degrees of freedom are just very, very high. And it is very, very limiting if you as a developer or you as a company don't understand the underlying mathematics very much, because the choice of options, the choice of how to formulate your problem, what is even worth doing, and so on. There's just so many degrees of freedom in the real world. It is rarely like a simple challenge on Kaggle, this popular website that does these data science competitions, where your problem is very bounded. They give you this one data set. It is known that one of these 5 or 10 methods have to work. There is some minor tweaking you can do, and virtually everybody gets to at least 80% as good as the best result. And most of the fight is about how do I realize the additional 0.5%, 1%, something like that. But that is not how real world machine learning goes at all. There are just too many degrees of freedom in a bunch of different spaces. Number one, there is a lot of degrees of freedom, I would say, within the space of value. And this is a very, very nebulous thing. Like in the real world, you're often solving a much more nebulous problem of how do I use machine learning to create the most value. That in turn means that one can formulate the underlying problems itself in a lot of various different ways. And somebody that does not understand business well, that doesn't understand product well, that doesn't understand a lot of the other things very well, is going to be somewhat limited. The other thing is certainly your various choice of modeling options. What do you do? Do you choose to get more data labeled? What would be the likely impact of various things? Again, I think not understanding the underlying mathematics leaves you very, very crippled in under that circumstance. Yeah, these are definitely two things I would emphasize a lot more. In some sense, both going a lot deeper into the mathematics, but also sort of looking at a 20,000 feet level of what are you trying to do and where does value actually exist. I think both of these will be quite important. I see a lot of industry machine learning efforts where these two things are not adequately done, and the company suddenly realizes that they are falling behind. They have to invest a lot in AI. They build out teams, but they fail in these two key areas, and consequently, they have a lot of wasted efforts and failed projects.
Awesome. So that was quite insightful, Vijay. So now a follow-up question to that is, what are some use cases and applications of AI and ML at Turing? And what does the future hold for AI and ML applications at Turing?
Good question. So first of all, at Turing, we are an obsessively data-driven company. And in fact, our ratio of data scientists to software engineers is something like 1:2, which I think would be unusually high based on what most companies do. I think in most companies, it might look a lot more like 1:10 or 1:20. Maybe for every 20 software engineers, they may have one data scientist. We, on the other hand, have maybe one data scientist for every 2 software engineers, roughly. And today, I would split our machine learning and data science activities into 2 parts. There is one thing to do with a lot of straight up, I would call it business analytics type of use cases. So this would be problems to do with customer LTV modeling, business process and operations optimizations, marketing analytics, things like that. Some of the more challenging problems, however, where a big chunk of our efforts, more than half our efforts go, is to do with better evaluation of software developers, better profiling of software developers, and better matching of software developers more generally. So over here, there are a number of challenges. I mean, a lot of people can immediately relate to AI at the level of effectively matching software developers to companies. And since I'm sure many people have heard a lot of companies talking about precisely this in the context of resume matching to jobs, for example. However, at Turing, it goes a lot deeper than this, because for us, the resume is a very small piece of the signal. We rely very heavily on developers' performance in our various tests and what that tells us about developers' strengths, their past projects on Turing with various customers of ours, and so on. So here we run into a lot of exciting and challenging problems, like even the problem of how do we design tests itself from first principles? Like today, for example, virtually nobody thinks in terms of machine learning for how to run a test or an interview process. But the way most companies do it is their engineering leadership or data science leadership probably has some thesis on what is important for success in their company. They run the interviewing process a certain way, and that's about it. At Turing, however, we have a lot of data to work with in terms of what actually predicts success, what actually ends up being maybe a waste of time and doesn't really give us much eventual marginal signal, and so on. Since when we are trying to build an effective profile of a developer, we are trying to ask the simple question of how do I make every minute count? How do I make sure I don't waste a software developer's time, and every minute I spend assessing them gives me some very material information about them? Now, what also makes this very heavily challenging is the fact that a lot of correlations exist. Obviously, there does exist something like being a good developer as a whole, and you can imagine that most of the different traits one wishes to assess in a developer have a strong positive correlation with one another. Now, the flip side of having a strong positive correlation with one another is that you often start hitting the point of diminishing returns after you test certain things, and you want to kind of, in effect, test for certain things that are fairly uncorrelated with other things that you've already tested for, and also have strong predictive power on what will eventually help a person succeed with one of our partner companies, should they be matched. So these kinds of problems have some commonality with the idea of active learning in machine learning, where one tries to essentially sort data for labeling based on what will generate the most marginal information gain. And in a sense, you can say that this is what we try to do at Turing by way of our tests. Additionally, there is also one more complication in our specific problem. Like often it is very tempting, and a lot of people's initial reaction is to think about Turing's matching and ranking problem as similar to a Facebook feed ranking problem or a Google search ranking problem. But it is not quite the same thing, because the value of generating one specific good feed ranking is not very high. Since these companies have to serve billions of these on a daily basis. That is not quite true in Turing's case. In Turing's case, we are engaging in an activity which is, at least I would say, conservatively somewhere between 100,000 to 1,000,000 times as valuable as one feed ranking on Google or Facebook. Basically, just because the economic impact of putting the right developer in front of the right job, and the resulting value that can be realized over the coming year or 18 months is very high, a lot bigger than how do you provide entertainment to somebody for 5 seconds in a feed ranking problem. So in a world where the value of our problem is something between 100,000 to 1,000,000 times as valuable as one feed ranking, we would obviously think about this very differently. So in our case, we can even have machine learning that in turn pulls on operations. So for example, there may be certain quote unquote, I would say, easy jobs where we have already done a high degree of pre-computation and we know who are the best people for the jobs. But there can be other jobs where we think there is some set of people based on the partial information we have about them, but we may feel like it might be helpful to engage in some operational activity to encourage certain people to take some more tests or do something else that gives us the amount of confidence in a specific match. So in a sense, we almost see our I wish I had a good analog, but I kind of like to think of it like something where our matching system both serves as a ranking system, but also as a sort of GPS for people in our operations team to tell them exactly what new information should be collected from whom in order to make a more informed decision. So this sort of thing obviously becomes a more complicated version of machine learning. Again, it has certain things in common with some of these active learning like methods as well. And yeah, this is not an area that is talked about as much, but this changes the game very much. And I do expect, again, that in future, as AI is helping disrupt a lot of traditional operations activities, a lot of those things may very well be similar to the sorts of problems we look at Turing.
That was really insightful, Vijay. Now really coming to the question that everyone's been waiting for. What is your take on the $1 trillion problem of matching talent with opportunity? And how do you feel that AI could help solve it?
Yeah, I think this problem becomes particularly more complex in this remote first world. So, in the old world, if you will, where all hiring was local or all important hiring was local, or the vast overwhelming majority of hiring was local, arguably the problem itself is less complicated. And while AI and machine learning could help improve things somewhat, the opportunity is just not as big. Because let's take the old school way of hiring, where a company here in Palo Alto wishes to hire a full stack developer with Node and React expertise within a 5 or 10 mile radius of Palo Alto. Now, this automatically shrinks the pool down to the people with those specific skills who live within the specific area and who are also available/interested in this specific job, which invariably ends up being a relatively small pool at any given point of a time. And this ends up being the case no matter what the location. In areas like the Silicon Valley, it ends up being the case not because there are not enough developers, but because it's a tight labor market, basically. In many other parts, there may just not be enough developers that meet your specific criteria in the first place. So at that point, if you have 10 candidates to choose from that sort of clear the hard constraints of the job, there's not a ton that AI and machine learning can do at that point. And on the flip side, again, in the old school way of doing things, I have a lot of friends that live in various parts of the US where there is maybe one software company within a 10 or a 20-mile radius of where they live. And certainly I know people like that in various other countries as well, in India and so many other countries. Now, under these circumstances, again, it doesn't matter what your interests are and what your ideal job is. If there's one software company within a 5-10 mile radius, that is probably where you're working. And really, AI and machine learning can't do a ton for you. But the game completely changes in this remote first world, where like today at Turing, we have software developers that come from more than 10,000 cities around the world, more than 140 countries around the world. Once you relax this location constraint, that changes the game completely. At Turing today, for every job opening, there are I would say there are conservatively somewhere between 10,000 to 50,000 possible developers we could be matching for that specific job. This is for our average job. Of course, there are certain jobs with the rare skills, but again, given the large size of our developer pool, more than 700,000 strong, there's always a very, very sizable number of developers there. And on the flip side, again, for each developer, there are again many hundreds of jobs they could be matched to in any given month. So here the novel opportunity really comes because we get to generate certain kinds of win-win outcomes that the world has never seen before. In local hiring, people, both companies and individuals alike, have always had to engage in very, very significant compromises. Like companies have had to engage in certain compromises in the kinds of people they would hire. They might hire people with a somewhat different skill set or a somewhat different background than what they would have ideally looked for, because there are just not enough number of people in their location, and vice versa. So here, like earlier in this podcast, I mentioned a little bit about the whole idea of trying to maximize the extent to which work translates into value. Now, one of the key components that ensures that work/collaborations maximize value is if you get the right two parties together. Like if you put a developer in front of a job that perfectly plays to their absolute strengths and where their current weaknesses don't hurt them, then that is perfect. That's a win-win arrangement for either side. And this is what ultimately also enables both parties to win, creates excellent value for money for the customer, still puts the developer in a great stage where they produce more and more value, grow in their career, grow in terms of compensation, responsibility, everything else. So this is by far, I think, the biggest thing. Now, under these circumstances, of course, it is also possible to sort of engage in a lot more long-range planning when you're a platform like Turing. In the old school way, it would be very hard for us to predict that a certain number of jobs are going to come from a specific geography and plan for that ahead of time. This is the reason why, whether you like it or not, a lot of AI for hiring companies in a local context ended up looking like old school staffing companies plus essentially. Really not, they didn't appear to change the game dramatically, because you really can't get that degree of predictability. But on a global scale, all sorts of standard forecasting kind of methods can be engaged in. We can make sure that there are already fully vetted developers for various kinds of jobs who are good to go the moment a job comes into the system. Like in a way, I like to think of this similar to a lot of popular methods used in computer science systems slash databases, where you try to pre-compute or cache the answer to certain queries to respond to them swiftly. Now, a lot of these are possible to do even for some other jobs which may be a little bit nebulous. It is still possible to engage in certain kinds of partial computation ahead of time. And even I think developer willingness to go through a certain testing process is a lot more in a situation like Turing, just because here they are not doing a series of tests to apply to one job. They are doing a series of tests to put themselves in front of many hundreds of jobs at the same time, essentially. So yeah, I think remote and relaxing these constraints suddenly turns this from this old school manual problem to this giant big data machine learning problem. Maybe not very different than what, like I would treat this shift not very different than old school online advertising, where there was no significant targeting or anything of that sort. This is like, yeah, maybe Yahoo back in the 90s versus to what, say, Facebook ad targeting is like today. So today, Facebook easily earns 10 times the amount of money from each page impression compared to what the companies did back in the day as a result of this hyper targeting. Like when you put the right ad in front of the right person, it can be very, very powerful and ultimately produce great results for the user, the advertiser, and the platform. It is the same here. When you put the right person in front of the right job and help make that collaboration work, that too can produce massive value for all three parties involved.
That's incredible. So what I'm taking away from this is what Facebook and Google are to advertising, Turing is to hiring and matching. Is that right?
Let's say we are in the early days of that. Yes, hopefully 3 to 5 years from today, I'll be happy to say that. I would love to say that we are exactly that. But yes, that is certainly what we aspire to be. Yes,
that's amazing. And another takeaway that I'm getting from this is that with the help of AI, we can turn this $1 trillion opportunity into a win-win for both developers and customers.
That's exactly right. I mean, we have seen how much value has been effectively unlocked as a result of increasing the sphere of effective collaboration itself. In fact, I've read certain sort of economic writings from that talk about the early 20th century and the impact something like the automobile had on increasing the radius of people's job opportunities. So when the radius of job opportunities went up from, say, 2 miles to 20 miles, even that was a game changer in terms of allowing I'm guessing going from 2 miles to 20 miles is like increasing the radius by a factor of 10. So increasing the area by a factor of 100. So presumably such a thing would increase one's job opportunities 100x. Now imagine what happens when you grow that to the diameter of the planet itself. So yes, absolutely.
Awesome. So now coming to the final phase of this interview and this podcast, Vijay, the final question for today is, according to you, what does the future hold for Turing as a company, and how will AI help in shaping the same?
Yeah, so I already talked about AI a great deal in the previous question. So maybe I'll just talk about what I see the future as holding for Turing. I would say that, I mean, obviously, with the pandemic and everything, if, people think specifically about Turing's rise amidst the pandemic. But the fact of the matter was that we were growing very rapidly, even pre-pandemic. I mean, the pure talent shortage pressures, the high costs of living in various urban areas and all that were nudging the world in this direction, but probably not as fast as what the pandemic did. Ultimately, I do think even in a post-pandemic world, this would just make for a happier and a healthier society with a lower carbon footprint, where people actually do what they love. I mean, if again, it can be difficult to lose sight of even how today compares with 50 years back or something like that. Ask your grandparents if they loved their jobs, they would probably say no. The purpose of a job is to earn money, basically, and that was the case with most of society. Now, a greater and greater percentage of people are in jobs that they love. And imagine extending that. Yeah, it's also very, very exciting to ultimately be creating something of a level playing field for talented people all over the world. Obviously, talented people exist in a lot of locations, but often local opportunities don't allow nurturing that talent very well. It's very exciting to be able to help level the playing field somewhat, and even more importantly, help a lot of very talented software developers from all over the world get the same exposure and work on projects of the same complexity as their Silicon Valley counterparts, which eventually allows them to grow much like their Silicon Valley counterparts. Now, there is a very real sense in which when Google, Facebook, and the other companies talk in terms of an IC3, IC4, IC5, IC6, and these kinds of levels, like a software engineer, senior software engineer, tech lead manager, and so on, it is not just an years of experiencing. It also comes because people have matured as software engineers, matured as leaders, understood what it means to own responsibility, not just write code that's assigned to you and all that. Enabling software developers all over the world to level up this way is a very, very exciting thing for us also. And yeah, I think there are massive numbers, hundreds of thousands, millions of extremely talented software developers all over the world. And again, when it comes to technology itself, there is no question in my mind, the biggest bottleneck to technology advancement today is shortage of talented software developers. So, well, at Turing, it is very exciting to be at the forefront of both helping technology itself of the world advance a lot faster than it would have otherwise, and expose the world's software developers to the most exciting opportunities there are.
Amazing. Thanks, Vijay. That was very insightful and great discussion overall.
Yeah, thanks, Krishna, for the interview. Thanks, everybody that could make it to watch this live today. And thanks to everyone that's watching a recorded version of this in future.
Yeah. Thank you. And with that, we'll be closing today's session. Thank you.